log laws and solving log equations. In this video we're going to go through the different log laws and how they are useful in solving equations. But first let's look at what a log is. Imagine you were asked 5 squared equals x. Well, you could put that into your calculator. 5 squared is 25, so x equals. Next, imagine you were asked x squared equals 25. Well, again, you could put that into your calculator, the square root of 25, and just say that you want the positive value, x equals 5. Next, imagine you were given 5 to the power of x equals 25. Again, you could probably work that out knowing that 5 squared is 25, so x is equal to 2. But then imagine you were asked 5 to the power of x is 31. Well, you know that 5 to the power of x equals 25, x is 2. So 5 to the power of x when x is 3 is 125. So 5 to the power of x equals 31 would be somewhere between 2 and 3. But it's going to be some long, laborious decimal. One that you wouldn't be able to find the answer to without the use of a calculator. But you can't solve equations to power on your calculator. So what you have to do is change it to a log. And we can change that to log. The base is 5. We want the answer to be 31 equals x. You can put that into your calculator. And that is exactly the same as 5 to the power of x is 31. So these two, 5 to the power of x equals 31, are equivalent. So that's why when you want to solve a power, you first change it to a log and then you can put it into your calculator. The answer to a log is a power. And you are given that formula in the formula booklet. There it is. A to the power of x equals b, which is equivalent to x equals log to the base a of b, where a must be greater than b, a must be greater than 0, b must be greater than 0, and a cannot equal 1. So let's go through a few examples and hopefully you'll be able to see a pattern start to emerge. So imagine you are asked log 749 equals x. Well, you could rewrite that as a power, so 7 to the power of what equals 49? Well, 7 to the power of 2 equals 49. So x equals 2. Next one, so log 4, 64 equals x. Well, you could rewrite that as a power, so 4 to the power of what equals 64? Well, 4 to the power of 3 equals 64, so x equals 3. So log 3, 81 equals x. So 3 to the power of what equals 81? Well, 3 to the power of 4 equals 81. So x equals 4. Log 5, 1 equals x. Well, 5 to the power of what equals 1? Well, 5 to the power of 0 equals 1. So x equals 0. If you ever have any log with 1 in the bracket, the answer is always equal to 0. What about log 2 to the 1 over 64 equals x? Well, if you know your powers, 2 to the power of a negative number if the value is on the bottom is equal to 64. Well, that would be 2 to the power of minus 5. So x is equal to minus 5. Now let's go through a few examples. The first rule I want to go through are the same base rules. There's the addition one and there's the division same base rule. They're called the same base rules because all the logs are in the same base. So the addition rule, log a to the x plus log a to the y is equal to log a x times y. And the subtraction rule, log a to the x minus log a to the y is the same as log a to the x divided by y. Imagine you were asked the following question. Log base 6, 24 plus log base 6, 9. What is that equal to? Well, because they're both log base 6, that is equal to log base 6, 24 times 9. Which is equal to log base 6, 216. 6 cubed is equal to 216, so the answer to that is 3. You can just type that into your GDC. Another question might be log 500 minus log 4. Well, that is equal to log 500 divided by 4, which is equal to log 125. So in other words, 5 to the power of what equals 125, or 5 to the power of 3 equals 125. So the answer is 3. The final question combining both might be log 4 32 plus log 4 8 minus log 4 4. Using the two rules, that is equal to log 4 32 times 8 divided by 4, which is equal to log 4 256. And that means 4 to the power of what equals 256. Well, log 4 to the power of 4 equals 256. Another type of questions we might get involve powers. So we might get something like this. Log 3, 81 squared. We could multiply out 81 squared and go from there, but we could use instead the power rule. Log a x to the power of m is equal to m times log a to the x. So we can rewrite this as it's equal to 2 times log 3 of 81. Well, 3 to the power of what gives me 81? Well, 3 to the power of 4 gives me 81. So that is equal to 2 times 4, which is equal to 8. The final law is the change of base law, which isn't used very often in the IB anymore, but you still have to be able to use it just in case. So you might be asked a question such as this. Log 4 to the 8 change to base 2. So you can use the change of base rule, so that is equal to log 2 8. The 8 becomes the numerator. Log 2 4. Well, log 2 to the 8 is equal to 3. Log 2 to the 4 is equal to 2. So that is equal to 1.5. So one last thing I want to introduce is log to the base e of some number, which we don't write as log to the base e. E is a very special number. It's Euler's or Euler's number, and it's equal to 2.718 ... We don't write it as log to the base e. We would write it as ln and the number. So ln and e are very special numbers. You know, they occur a lot in compound interest. So later on you might do an investigation or an IA on compound interest. So you would see ln. Right, all the above laws apply to log in base e. So the addition rule, the subtraction rule, the power rule, all apply. So you might be asked a question such as, what is the answer to ln e to the power of 4? Well, you can use the power rule. Well, that's equal to 4 ln e, which is equal to 4 times 1. And the reason it is 4 times 1 is ln e could be rewritten as log e to the e, and anything with the same base and number is equal to 1. So the final answer is 4. This is a typical non-calculator paper question. Solve the equation log base 3 of x squared minus 4x plus 2 equals 1 plus log base 3 x minus 2. The first thing to do is you need everything in log base 3. 1 is easy to change to log base 3. Log base 3 is equal to 1. Therefore, we can rewrite this equation as log base 3 x squared minus 4x plus 4 equals log base 3 plus log 3 x minus 2. On the right hand side, we can use the multiplication rule. So we've got log 3 x squared minus 4x plus 4 is equal to log base 3 of 3 times x minus 2, which is equal to log base 3 of 3x minus 6. And we've still got the same on the right hand side. because both sides has the same base, we can remove the log part. So we get x squared minus 4x plus 4 is equal to 3x minus 6. Therefore, rearrange to get x squared minus 7x plus 10 is equal to 0. Factorise into two brackets to get x minus 2, x minus 5 equals 0. Therefore, x equals 2 or x equals 5. X equals 2 cannot be a solution because if we look at this part of the equation, log 3 x minus 2, if we put 2 into that equation, we would get log 3 0. And there is no such answer to log 3 0. So therefore x equals 5, only solution.